Hello, ladies and gentlemen. Today we're going to be talking about probability because that's half of the name of this course. So we've talked a lot about statistics and how we work with numbers in order to create what people call statistics, and now we're going to be talking about probability. So what you're going to need is a pen or a pencil, your notes, and then maybe a calculator, depending on how good your math skills are. First, the question that we should ask is, what is probability? Probability is the chance of something happening. It is used to quantify what the odds are for a specific event and to see if that event will occur. So you guys probably know lots of games that are called What Are the Odds? That's all based on probability. So why does probability matter in general? So this is why teens pay higher insurance rates than adults, and even why males pay higher insurance rates than females. This is for car insurance, of course, because track record shows that men have a higher probability or a higher chance or a higher likelihood of getting in car accidents than females, and the same thing with teens and adults. That's another reason I just said that. And then likelihoods of getting picked for contests and drawing things out of hats and all that stuff. That's all stuff related to probability. So when you hear the word chance, when you hear the word odds, when you hear the word likelihood, that's all typically going, and there's numbers attached to it, that's all typically going back to probability. So there's different types of probability, and we're going to talk today about the first four listed, and then there's going to be another video on the last one. So the first type of probability is called basic probability. Basic probability is just like counting. So you're going to count the number of the desired outcome divided by the number of the total outcomes possible, and we'll look at what that means with some examples. So the formula for basic probability, if you will, is called number desired divided by number total. Complement probability or complementary probability is what is called usually not probability. So when someone says, what's the probability of this not happening? Sometimes it's easy to count that possibility happening, and other times it's easy to just take the 100% minus the probability of it actually happening. Or probability, when you hear the words like find the probability of this or this happening, that means that you're supposed to add the numbers of those two events happening. And then when you see and probability, that means you're supposed to multiply the numbers of the probability that's been given to you. And if the probability isn't given to you for the and or, then you're going to have to find it probably using basic probability again. And then the last one is called conditional probability, and the formula or how you solve for those is you figure out a new total in the bottom, and then you do number desired over number total. And we'll dive deeper into a separate video all on conditional probability because conditional can be a little confusing. So today's lesson is going to focus on basic, not, or, and probability. So with that, we have 8 examples, with number 1 being multiple parts. So a card is selected from a deck of 52 cards, so a regular deck of playing cards. Find the probability of the following. So if you don't know what is in a regular deck of playing cards, there's 4 suits. This suit is clubs, this suit is diamonds, this suit is hearts, and then like an upside down heart is spades. Each suit has 13 cards all the way from ace to 10, and then jack, queen, king. So so if we take 13 times 4, the total number of cards is 52, which was listed here. So the first question is, and this is all notation with probability, when you see P parentheses, it's saying what's the probability that a heart is drawn from the deck of cards? Well, there's 13 hearts for the suit, so it's 13 out of 52. For probability, you can write it as a reduced fraction or a percentage. Just for the sake of me not having to punch stuff into my calculator, I'm going to just reduce the fractions. But if you want to answer with percents, that's totally fine. So 13 divided by 52 is 1/4 of the deck, and that's as simple as that fraction goes. Part B, what's the probability of drawing a 6? Well, there's a 6 in each suit, so that means that there's 1, 2, 3, 4 sixes, 4 out of 52, which can be reduced down to 1 out of 13. That's your chances, 1 out of 13 odds. What's the probability that we draw a black card? Well, 2 of the suits are black and 2 of the suits are red, so that means that it's half of the deck, or 26 out of 52. What's the probability that you draw a card that is less than 3? So I know that some rules talk about aces being higher than kings, but still aces are considered as a card with a value of 1. So I'm going to include aces and I'm going to include 2s. So cards that have a value less than 3. So that would be all the aces, which is 4, all the 2s, which is another 4. So it's going to be 8 out of 52, which can reduce down to 2/13. What's the probability of drawing a face card? Face cards are all the things that have people's faces on them. So that's the jacks, queens, kings. So that's 3 times 4. So that's 12 out of 52, and you can reduce 12 out of 52 to 3 out of 13. What's the probability that we draw a 5 of spades? Well, there's only one 5 in the one suit of spades, so that would be 1 out of 52. And then the last question is, what is the probability of drawing a green card? Well, we don't have any green, we only have red or black, so that probability would be 0 or no chance. So this is all of these examples were basic probability, where all we had to do was know what the deck of cards was and then count it out and reduce the fraction. So that's all examples of basic probability. So if you want to write that down, that this is basic probability, you sure can. Okay, example number 2. If you roll 2 dice, what's the probability of the sum being a 7 or an 11? So when you roll 2 dice, you have 36 outcomes. You can roll a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6, a 2 and a 1, a 2 and a 3, all that stuff, right? So it's listing all of them. And because the 2 dice are independent of each other, you have to include like the 2 being rolled on the first dice and the 1 being rolled on the second dice, and the reverse. So the 1 being rolled on the first dice and the 2 being rolled on the second dice. So the question is, what's the probability of getting a sum of 11 or 7? So let's count how many sums could be 7. So we have 6 and 1 add up to 7, 5 and 2 add up to 7, 4 and 3 add up to 7, and we have to count the reverses of them. So 3 and 4, 2 and 5, and 1 and 6. These all add up to 6, 5, 4, 3, and 2. These all add up to 8, 9, 10, and then 11 would be here. So you probably saw already that this said or. So sometimes with or, like because we have the sample space listed out, we're just counting the 7 and the 11. So when we say the 7 or the 11, technically we should be adding these probabilities. So the probability of rolling a 7 was 1, 2, 3, 4, 5, 6, 6 out of 36 options, and the sum of rolling an 11, or the probability of rolling the sum of an 11, was 2 out of 36. So technically we were supposed to add those together, which is 8 out of 36, which can be reduced if you take out, oh my gosh, this should be super easy. Yeah. Okay, if you take out a 4, you should get 2 ninths. I was just double checking. So 2 ninths is your probability. But if you just wanted to count 1, 2, 3, 4, 5, 6, 7, 8 out of 36, that's the same thing. So sometimes it's easier, depending how you think about it, you can use the addition rule, or you can just count it and call it basic probability. But this one was or probability, and this is how you would have added them, or you could have just counted them outright. But your final answer is 2 ninths. That's your simplest fraction. Okay, so number 3. What is the probability that a person does not draw a number 2 card from a regular playing deck of cards? So here's our deck of cards again. So we know that there's 4 number 2 cards in the deck. So it's 4 out of 52. And so they're saying, what's the probability that a person does not? This is the complement. So this is complement. So this is complement probability. So we're saying, what's the probability that the person does not draw a number 2 card? So that means that there's 52 cards in a deck, right? This is the chances of drawing a 2. So we need to take 100 or 1, or 52 out of 52 minus 4 out of 52. And that's going to be 52 minus 4 is 48 all over the total. is 52, and then you can reduce 48 over 52 to 12/13, which is your final answer. But the point is that sometimes it's easier to just subtract than to try to count all of the cards other than twos, because that would have been ridiculous to count all 48 of those cards. So when you see the word does not, there's probably going to be some sort of subtraction. Means you subtract. Okay, perfect. That's what complement means. So that was an example of the complement. Okay, number 4. When picking one card, what is the probability of drawing a face card or an ace? So see that this is an or probability, so that means that we're going to have to add. So we have total possibilities of 52 for both of these because we're back in a deck of cards. So what's the probability of drawing a face card? Well, we already knew that that was 3 face cards times 4 suits is 12 out of 52. And then there's 4 aces, 1 in every suit. So that's going to be plus 4 out of 52. So 12 plus 4 is 16 out of 52. And you can reduce 16 out of 52 to 4/13. So that was another example of or probability. Okay, looks like we have another or probability. So 2 dice are rolled. What is the probability that the sum of the 2 dice together is a 6 or a 9? So that's back to this. So let's look at 6, 5, and 1 add up to 6, 4, and 2, 3, and 3, 2, and 4, 1, and 5. So that's 1, 2, 3, 4, 5. So that's 5 out of 36 plus a sum for 9. That's going to be 6 and 3, 5 and 4, 4 and 5, 3 and 6. So that's going to be 4 out of 36. So then 5 plus 4 is 9 out of 36, which can be reduced down to 1/4 or 25%. So that was another example of or probability. Number 6, a coin is flipped and a dice is rolled. Find the probability of getting a head on the coin and a 4 on the die. And, so you see and now. That means that we're going to have to multiply. Okay? So when we talk about 2 independent things happening, so we have 2 different events happening, which means we're going to have 2 different kinds of probability going on. So a coin is flipped. So probability of getting a head on a coin is we're going to be multiplying the probability of getting a head on a coin, and then we're also going to be multiplying that to getting a 4 on a die or a dice. So the probability of getting a head on the coin was 1/2, 1 out of 2, and the probability of getting a 4 on a 6-sided dice is 1 out of 6. So what you're going to do with those 2 probabilities is multiply. And remember, when you multiply fractions, you take the top times the top, so 1 times 1 is 1, and you take the bottom times the bottom, so 2 times 6 is 12. So your final answer is 1/12. If you wanted to plug this into your calculator, you need parentheses. So if you do 1 divided by 2 times 1 divided by 6, that's the only way you're going to get back to the correct percentage for 1/12 is if you use those parentheses. So that was an example of and probability. Okay? All right, and example number 7. So we have 2 cards are drawn at random from a regular plain deck of cards. We want to find the probability that both cards drawn are kings if the first card is not replaced before the second card is drawn. Okay, so we're trying to look for keywords like not, and, or, whatever, right? So reread the question that's asking us what we need to find. So it says find the probability that both cards drawn. Usually when you see a both in a probability question, that means and. So we need to find the probability that a king is drawn and another king is drawn, but on the condition that it's the first card is not replaced before the second is drawn. So since we know that this is and, we're going to have to multiply. So there's how many kings in a deck of cards? There's 4 kings out of the 52. And then if we don't replace so let's say we draw a king out of the deck. Let's assume we draw a king out of the deck and we set it aside and we go to draw another card. Now we're 1 card down of the whole entire total, So we subtract 1 from 52, right? And then if we assume that the first card we drew was a king, that only leaves us with 3 kings left. So now when you multiply this, you're going to have to do some ugly multiplication because they're big numbers, but you're taking the top times the top, so 4 times 3 is 12, and you're taking the bottom times the bottom, so 52 times 51 is 652. So this is a really gross fraction because it's so big of a denominator, so I'm just going to convert that to a decimal. So that if you punch it into your calculator, it's 0.0045 yada yada yada, right? So this decimal, whenever you guys find percentages, so if you actually take like 1 divided by 4 and you get 0.25, in order to turn that decimal into a percentage, you have to multiply it by 100 or move the decimal to the right 2 spots. So our actual chances is not even 0.5% of drawing 2 cards that are both kings in the deck. Okay, now let's look at the second part. So they said find the probability that both cards are kings if the first card is replaced before the second card is drawn. So we have a 4 out of 52 chance the first time, and so if we drew a king that first time and we put that king back in the deck and shuffle the deck, now we're going to draw again and we have the same odds, 4 out of 52. And since we're trying to figure out if both or if and both kings are happening, then we have to multiply them. So 4 times 4 is 16. 52 times 52 is 2,704. That decimal is 0.0059. If you times that by 100 or move the decimal right 2 places, our odds are 0.59. So it was a little better, but it's still not even 1% chance of drawing 2 kings out of a deck of cards. So that's crazy. Okay, ladies and gentlemen, so that was basic probability, complementary probability, or probability, and probability. So that is all that I have for you are these 7 examples, even though it was a little more than 7 because we have multiple parts in these questions. But hopefully you took some good notes, and make sure you get those first rules written down. If I go back, make sure you get this stuff written down, that basic probability is the number desired over the number total, or just counting what you want or the outcome over how many possible outcomes there are. And then complement is 100% minus the probability of it happening, or means you add, and means you multiply. And we will be back here shortly to talk about conditional probability. Thanks everybody, and have a great day.